All right. Hey, everyone. Welcome to the June 22nd dev call. We will kick this off talking about priorities and then move on to some of the major uh, FIPs that we have on deck. So priorities as usual. First one is permissionless hubs. We're mostly there. We have over 20 hubs, maybe close to 30 running right now. A lot of the focus right now is on bug fixing and stabilization. There's new stuff that people are finding every week. Thank you for reporting those issues. And the team's focused on catching and patching them. The second focus is permissionless signups. So this is actively being designed and being worked on right now, but it's actually getting us to a point on mainnet where any application developer can sign up users and take them through the entire onboarding flow and turn them into active Farcaster users. So there's a lot of work going into this, and this will be the main chunk of what we're going to talk about today. And the third category is features. So any new features that we're adding where we have extra cycles to do existing work, or new features that we want to get started on the design phase that we will ship once the migration to mainnet and the permissionless signups are completed. So that's roughly how the team's time is being allocated in terms of prioritization. So permissionless hubs, there's two known issues that we're actively working on. The first one is Tony's been working on a fix for some Warpcast data that's actually not being broadcast to hubs. So the data is being created on Warpcast and Warpcast isn't actually broadcasting it over. This affects a small number of users, and we have a fix for it that's being shipped. It's a client-side fix, so it's going to take a little while to roll out because we actually have to update all the various clients and ship this out. The second problem affects hub operators. So there's a known issue right now that if you leave the hub running for a long time, it starts consuming more and more storage space and will eventually run out of space unless you restart it periodically. This is a bug due to some open iterators that have been left in the RocksDB instance. And so there's actually a fix for this that shipped last night. We have a new patch version of the hubs out called 1.3.1. So if you're running hubs, we recommend upgrading to this, and this should resolve the issue. And if you do happen to see any more large storage consumption or any other issues, let us know so we can continue to debug. There have also been one or two reports of stalls. I don't think we have enough information to debug this yet. So if anyone runs into these situations, particularly if your hub stops responding, please leave it in that state and let us know. And we would love to debug a live instance of this, since that will actually help us get to the root of it. Cool. This is all the known issues we have with running hubs. If you're running a hub and you're seeing stuff that's breaking or not working beyond this, please let us know, and we'll prioritize fixing that. We also shipped between the last dev call and this one, the new links FIP, which allows follows and other kinds of data to go out. And Warpcast published all of its follows data on the 16th of June. So right now, if you go to the hub and you query for follow data, you should be able to get all the follows that are on the network. And you can also write and create your own follows using signer messages. Two other FIPs that we talked about last time, the canonical serialization. So this is the issue where if you use different libraries to produce the messages, you might get different results and have issues talking to hubs. And the multi-signatures, which is a nice UX improvement for when you wanted to change the address that owns your Farcaster ID. We've postponed both of these. I think both of them ended up being a little more complicated than we originally anticipated, and that pushed them lower down the priority stack relative to getting to mainnet. So we still have some designs, we have some conversations going on about this, but we likely won't ship this until we get on mainnet. Any questions on this stuff before I jump over to the new features or the permissionless signup stuff? Cool. So permissionless signups, there's basically four stages of what we're doing here. The first three are happening in parallel, and then the last one is the release phase. So we're going to make a decision on which L2 Farcaster's identity and storage are going to live on. We've talked about why we're moving to an L2 before. Largely, it's to lower costs. And we're talking to many of the L2 teams, and we're going to make a decision by the next call. The rough criteria for how we're thinking about this is one, we want something that is simple, fast, and easy to ship. We want to make sure we get on this L2 really, really quickly. Two, we want to make sure that the cost benefit of actually moving to this L2 is significant. So there needs to be a significant cost reduction between being on L1 and on this L2. Three, we want to be on an L2 that has a credible path to decentralization. I think realistically, most L2s are very early on their journey to decentralization and are still building their mechanisms. I mean, some are a little ahead of others, but in the grand scheme of things, people are still pretty early. And so we're going to pick something that has a credible path to achieving decentralization. The important thing guiding all of this is the decision is not permanent. It's quite feasible for Farcaster to take its contracts and move them to a different chain or even its own app chain in the future if that's the right solution. So we're roughly thinking of this as like, given that we will be on an L2 for the next 1 to 2 years, and during a time when L2s are still figuring out decentralization, what is a solution that allows us to get shipped quickly, safely, and that has low cost for users? And we're going to be picking that one. Greg had a question on whether L2s will house FID and storage contracts. Yes, those are the two contracts that will be on the L2. In addition to, when we talk about ENS usernames, there's going to be a third ENS resolver. That one's actually going to end up on the main L1. So the FIDs and storage will be on the L2. Folks have any more questions on this before I move on to ENS usernames? Nope. Great. So for ENS usernames, we're doing this thing where I'm trying to record a little video that's like a high level. Here's how the FIP works, so folks can watch something before they come into this call and get context. So we've linked the videos down here. If you haven't had a chance to watch them yet, you can watch them after this call. I will briefly go over the FIPs. So the ENS usernames FIP has two important changes. One, it's going to make the existing Farcaster names, which are currently on-chain names, it's going to take them and move them to being off-chain names. So the names are actually going to be issued by a server that lives on AWS, and that's what's going to control the issuance of the names. But we're going to use ENS's CCIP approach to actually make sure that those names can be resolved on-chain, just like ENS names. So there will actually be a contract on ETH-L1 that can resolve those usernames, and any other contract calling them is able to verify that, Greg owns at Greg or Varun owns at V, or any of these other properties. So it makes it actually composable with the ENS ecosystem while reducing 2 transactions and a significant amount of cost from the original sign-up process, which is just going to make it a lot easier for people to sign up. So that's change number 1. Change number 2 is hubs are going to make ENS names, both the L1 ENS names, so the .eth names on Ethereum L1, as well as the Farcaster ENS names, the one stored off-chain on the server. It's going to make both of them very easily accessible to developers. So you can give an FID and you can say, hey, give me the ENS name that this person's using. You can even ask it for all the ENS names owned by this person across all their various addresses. So if they have multiple, you'll get that list. And you'll be able to resolve the opposite way. You'll be able to give it an ENS and get the FID associated with that. So it's going to make it very easy for Farcaster apps to be able to show an ENS name for a user and be able to resolve an ENS name to an FID when they need to publish messages. Cool. Any questions on this?
Yeah, a quick one. Did you guys choose the Farcaster.xyz thing over .eth as just like a direction?
So we are still debating on what domain we actually want to use. The nice property of using something that resolves in the web is the users could then potentially have a domain that actually resolves to something under their control versus .eth doesn't necessarily resolve in all browsers today. So right now we're leaning towards something that resolves in the browser. It may not be Farcaster.xyz, it may be something else, but that's the current plan.
Cool, that makes sense. And sorry, I'm in the airport, it's pretty loud. Will the, whatever you choose, so Farcaster.xyz, for example, be abstracted in the Warpcast client or at the hub level, or not at all?
What do you mean by abstracted?
So like today I'm at Greg on Farcaster, or on Farcaster, I guess. And will that be Greg.Farcaster.xyz, or will that still be like seen as just Greg on Warpcast?
So it's a good question. At the ENS level and at sort of the data level on the hubs, names are going to be treated as their full ENS resolved names. But I think clients will likely truncate the Farcaster suffix to make it easier to address Greg. So it's not Greg at Farcaster.xyz, it's just at Greg ends up always representing at Greg.Farcaster.xyz, and at Greg.eth represents Greg on the L1 chain.
Sweet, makes sense. Thanks.
Cool. Manan, you had a question?
Yes. So I was a little confused about the one-to-one relationship between ENS names to addresses resolving and verifications that will be on L2s on the storage. are there any conflicts with regards to linking multiple verifications, but not having addresses kind of have ENSs or F names available?
So the way we're setting up the system is a couple of things. One, you have two different kinds of addresses. You have your Farcaster address, which is the core address that you sign up with, and then you have verified addresses that you can link later on that may have other ENS names associated with them. So your Farcaster address is going to own your .farcaster.xyz name. Let's call it that for now. And everyone, at least if you sign up on Warpcast, will be encouraged to get one of those because it's free and easy. You don't have to connect an external address. It makes the sign up process super simple. Once you're done with that, you can connect a verified address. And at that point, any ENS names that resolves to that address, and we're going to use kind of the standard recommended ENS resolvers to check for this, is now a valid name that you can claim and use on Farcaster. And there'll be a nudge in the Warpcast app that says, hey, you've now added this address. You now also have, foo.eth. Would you like to use that instead? And you can kind of go to settings and change it at any time. So importantly, a user can have n different names associated with one or more of the addresses that they own. And a user can also select which one is their primary name at any given point in time. So you can go and say, hey, I would like everyone to refer to me as, at Manan and not Manan.eth, and that's what I'd like to be called. And then that will actually be set in the hubs, and app developers can pull for that and see that.
Okay, yeah, that makes sense. Thank you.
Cool. And Bill, I know you asked the question about person A owning name.eth and B name.farcast.xyz. The way it'll work is .eth names will have the full suffix. So if you want to tag at name.eth, you actually have to type at name.eth, and that will tag the eth thing. And if you just want to tag the Farcaster.xyz, Warpcast will, if you just put at name, Warpcast will assume that you meant the Farcaster.xyz username because every user has one of those. But if you extend it to .eth, then Warpcast will automatically associate it with the L1. Cool. And as we get closer to shipping this, we're speccing out the APIs for how you can get and set F names. We'd love to get, ENS names. And we would love to get feedback from folks on, are these APIs enough for you to build your applications and resolve usernames correctly in your application? Because there is a bit more complexity. Today, you just largely have a one-to-one mapping, and now you're going to have a one-to-many mapping with a primary name that you can then use in your applications. The one interesting part of this, we've talked about this a little in the spec, but somebody could change their name every 30 seconds or write a bot to do that. And I think this is something that will kind of push down to the application level and say, hey, apps can decide what they want to do if a user is constantly switching their name. Is that actually confusing from your UI? Do you want to implement a delay that says we will only update the cached name once every hour or something like that? I think some sort of delay there is reasonable. Warpcast will probably pick something like, hey, we'll update this cached value once a day. And if you're doing it more often, we'll just keep it consistent to make the UX easier. Cool. Moving on to flexible storage. So flexible storage is another proposal which solves a big problem of going to mainnet. So the main challenge we have is constrained space, right? Fundamentally, there's a limited amount of space that hubs can reasonably store. And if you tell users, hey, you can put whatever you want on this network, people could upload 1 billion messages. It would be impossible to operate a hub, or it would become very, very expensive. You wouldn't have a lot of hubs, and it would become a centralized network. So we want to say, hey, there's a finite amount of space available, and how do we divide it fairly amongst all the users who want to publish messages? And the way we've done this today is very simple. We've said, 1, we'll limit the number of users that can sign up, and 2, we'll give each user a limited amount of space. This doesn't work for 2 reasons. 1, we're going to take that restriction away. We're going to allow everybody to sign up. And so, you can make 1 million accounts if you'd like, and you can flood the network that way, which is problematic. 2, it's actually not ideal to have everyone have the same amount of space. Some users are lurkers. They almost never cast. And, we still allocate the space to them that never gets used. Some users are very active. They cast 100x. Stuff they produce is valuable, and it would be nice to preserve that on the network. But right now, all of that stuff gets expired away. So flexible storage adds a nice balance where it gives users the option to acquire storage by paying for it. So there's a contract on chain where you can go and say, hey, I would like to buy a unit of storage. And what we do is we take up all the storage space on the hub. Let's say there's, to make the math easy, let's say there's a gigabyte of space. We divide it into 1,000 units and say, hey, here's each, approximate megabyte of space. You can buy 1 unit, and then you get X messages that you can store, which translates to a certain number of casts, reactions, etc. And that's yours. And if you would like more space, you can make another transaction to this contract and buy another unit of space. And now you can store twice as many messages. And so it's a more market-based system where people can come in and acquire more or less storage based on what they would like. And it also adds a natural filtering function where, because of the price and the on-chain transaction involved, users can't just grab like 10 gigabytes of space and overload hubs. There's a lot of subtlety to this proposal that's covered in the spec. I won't go into all the details on this call, but at a high level, do folks have any questions about this?
What's the starting amount of space that each person would have? Like, how would you determine that? Is it just evenly divided amongst all the users?
So we're still finalizing the exact, like, what is 1 unit mapped to. So we're still working on the, hey, 1 unit equals XYZ messages of space. We're just doing some math on how much this actually takes on disk. The way this will work is every user, when they just grab an FID, starts with 0 storage, and they have to make at least 1 transaction to the storage contract in order to get their storage. So when you sign up, you can think of it as like step 1, register FID. Okay, great, I have an FID. Step 2, acquire 1 unit of storage, and that's your base level of storage. And users can then go choose to acquire 2, 3, 4, 5 units of storage if they would like. Greg, you had a question?
Yes, similar to the way today usernames or names and FIDs are batched. Will that be the case with storage, or like a base level of storage and an FID, or is it 2 separate transactions and it doesn't really matter because it's on an L2?
Well, it's on an L2, so it'll be dramatically cheaper, but we'll make a way for you to batch it and do it in a single transaction, so you don't have to pay double the transaction fees. So the overhead of the gas costs for the transaction, I think we should be able to keep under $1, probably a lot lower, especially as 4844 and a lot of these others things are going to come up. Manan had a question on, can others pay for storage? And the answer is yes. So the way the storage contract is designed is like an application can pay for storage, the person that invited you can pay for storage, or any combination thereof. So it makes onboarding easy by allowing anybody to come in and onboard users. Wallflower had a question on, are users not going to have default free storage? So yes, the way this design works is if we want to allow unlimited signups, we have to impose a sort of constraint on what people can do when they sign up. And because L2 gas costs are basically close to 0, we do have to have a fee there to prevent people from just creating like 1 billion accounts and flooding hubs. So each hub has a cost associated, each storage unit has a cost associated with it. Cool. So the overall aggregate of all of these changes put together, I think when we were originally thinking of launching on L1, the costs of signing up and acquiring an F name were probably going to be $5 to $15 at current prices, plus whatever you had to pay to actually get the transaction settled. And there would be a total of 3 transactions. I think now with flexible storage and ENS usernames, we're actually going to have 1 transaction. It's going to get you your ENS usernames and FID, and it's going to cost somewhere in the ballpark of $5 to $6, most of which is storage costs and very little of which is on-chain costs. And so that's going to let people sign up pretty quickly. And the reason we chose $5 as a starting price, it's similar to what ENS charges for a year. It's similar, it's half of what domain names charge. It seems like a reasonable starting point. I think that the truth is we don't know exactly what that number should be. And over time, it might be a more market-based system where if supply of storage exceeds demand, then costs will keep dropping until users sign up. And if demand exceeds supply, costs might go up to make sure that it's allocated a little more fairly. I think what we wanted to do with this initial system is we wanted to keep it as simple as possible and manually tuned so that we can update the price as needed and make sure that the system is working as intended. Cool. Last thing, Greg, you had a question?
Yeah. if this is a little too far out, feel free to stop me. But is the idea here that the storage payments go to like a protocol contract treasury type thing, and eventually like goes towards hub operators, because ultimately those are the people that are like paying for the storage or like hosting the storage? Or is that like not a consideration right now and kind of a long-term thing to play around with?
So it's a good question. I think the goal is it will be long-term. It will be used to drive protocol growth in some meaningful way. And I think it'll come down to one of two things, right? One is if you have a way to compensate hub operators fairly, then you can take up some of these funds and divvy them. Two, if you can reinvest that money to make hubs cheaper and more efficient to run, i.e. if you can use that money to pay developers to come and optimize storage and reduce costs of running a hub, that's another useful way you can allocate it. So those are the two things that we think will be possible. However, I think realistically for the next 1 year, with the size of the network and the amount of fees we're charging, this is not going to be a significant amount of money. We're talking maybe $10,000 or thereabouts. And so what we have said for now, and this is kind of in the FIP, is we're not going to worry about how to allocate or how to proportion this money until it reaches some threshold of significance. And then once it's there, we can start thinking about like, okay, now how do we actually go and use this money to incentivize stuff? Wallflower had a question of like, can prices start low and be adjusted up when spammers show up? I think a market-based approach is roughly what we're trying to get at, and we want to start with, picking a decent price and adjusting it. What we didn't want to do was start too low and then have a bunch of spammers join the network on day one when we get on mainnet and make it an unpleasant experience. I think that makes life harder for users and app developers. We also didn't want to start on the opposite end of being so high that nobody signs up. So we've kind of started picking something that's reasonably in the middle, basically something where we've seen other people in the ecosystem are paying for, i.e. ENS names and domain names. And we'll launch that and see how it goes, and then tweak the price up or down, maybe every couple of months to make sure that we adjust this. Cool. Last piece on mainnet release. So we want to get these two features shipped in the next month. So we're targeting ENS usernames. Will be released with the protocol with the 7.12 update. So that's next month. But because it's a backwards compatible change, we might start shipping some of the changes sooner. So no changes to users or app developers, but under the hood, hubs will start talking to the new contracts and pulling in data from them. With flexible storage, we're actually going to start prototyping and launching the contract on an L2 just to see how it all works. Again, no impact to users. Everyone will just get one free unit of storage. So your net storage limits are exactly the same as they are today. And then when we get to mainnet, we'll actually relaunch it. And one thing we're going to do is we're going to grandfather in all the users that are on the platform today for the first year. So everyone will just get 1 unit of storage automatically when the hub launches, and the cost will largely go to new users or existing users who want to upgrade their storage limits. And then once all that's done, we have to do a whole audit, testing, and release phase. We think that will realistically take between 2 and 3 months. And so we've allocated some time to get all that done and actually get launched on an L2 mainnet. No, so it's actually 6:30, Greg, because it's backwards compatible. So we might actually start having the hubs pull in some of that data sooner, even though the protocol technically releases only every 6 weeks. So the protocol update will happen on 7.12, but the actual hubs will start looking at this data a little sooner, and the APIs might become available before that. Basically, it might be available in an unstable form before 7.12, and you might see it in the hubs, but 7.12 is when it's like done and ready to use. Cool. 2 features that I think are worth talking about really quickly. The first one is instant recovery. So one of the things that we've been thinking about at Warpcast, and I think this will affect all application developers, is how to do recovery when people lose their seed phrases. And I think this is fairly significant. I don't know the exact numbers, but I would guess something like 10% of users have at some point in time lost their seed phrase and needed to restart, which is significant. And the current recovery system built into the contracts allows people to nominate a recovery address, but it has a delay. And so the way it works is when I sign up for Farcaster and I grab an FID, in the FID contract, I can nominate a second address that can recover my ID. And at any point in time, that recovery address or that second address can initiate a request to transfer my FID out to a new address, but the request doesn't go through for 3 days. So 3 days have to pass, and then that recovery address can come along and say, okay, I would like to complete this request, and then it moves the FID over. And the original intent for this delay was to allow semi-trusted recovery. So it would allow you to nominate somebody who's a recovery partner, but in those 3 days between when they start and complete the transaction, you can cancel it if they did it in an unauthorized way. So you didn't need to fully trust this person. If they started behaving maliciously, you could come along and cancel this. And that was a nice, property where it allowed you to maybe trust people that you didn't want to, fully trust with your identity, like a third-party service and whatnot. I think there's 2 challenges with this. One is the 3-day delay is really painful. Like when you lose your account, you come back, you want to log in, and someone's like, go wait 3 days and come back. It's a really, really frustrating experience for a social app, and people don't want to deal with that. 2, I think people tend to be more barbell in how they think about their recovery strategies. I think as we've talked to people, there's largely 2 groups of users. There's people who are, hey, I already have a primary Ethereum wallet. I have it set up with my ledger. I have it very secure. Just let me use that as my recovery system. And the delay is annoying. I don't want to delay because I control that other account. I just want to be able to complete it. And the other group is people who don't have that set up and who are kind of new to the ecosystem, who are like, I don't really care about semi-trusted or trusted. Let me just give this to the application that I use and have them do the recovery. And again, I would like it to be immediate. So we had a lot of this complexity and UX slowdown that like had these nice properties, but that nobody really wanted to use. And so we're simplifying recoveries to say you can nominate an address, and at any point in time, that address can move your FID to a new address. So it's a trusted recovery setup, but you can set it to your own wallet if you want it to be fully self-custodial, or you can set it to an application like Warpcast or Jam if you'd like to trust them to recover your address on your behalf, and they can do email recovery and all of that. Greg has a question on like, should there be an optional delay? I think this is a great question. We talk about it in the FIP. So adding an optional delay, I think, is cool, but it adds a lot of complexity to the contract and a decent amount of cost to setting up and signing up. And I think the right way to implement an optional delay is actually to have a smart contract wallet. So the correct way, I think, to have all these like highly configurable parameters is rather than storing it in like your basic EOA wallet, which is what Warpcast does today, you can give users an option to deploy a smart contract wallet, and then you can customize it any which way you like. You can add optional delays. You can add multi-sig where you have to have 2 people come together and then do it in order to recover your address. And there's lots of configurability there. And that felt like a much better way of doing it rather than trying to design our contract to presuppose all of these different permutations that you'd need. So the proposal is keep the contract simple, fully trusted recovery, very basic. We'll get us started. We'll get a good recovery system for most apps. And then users and apps can upgrade to smart contract wallets as those become more popular and compose any kind of fancy recovery system that they would like using that as a primitive. Cool. It's fairly straightforward change. Would love to hear from folks if they have use cases that would be made impossible by this, or if there's any pushback on this. But in general, this sort of lines up with our keep things simple, move quickly, get something out there that gets people the user experience they want while allowing for a decentralized experience. Greg has a question on, is Warpcast going to make it easy to set recovery address? The short answer is yes. I think we haven't done it. Honestly, we need to go build this out. It's just been on our backlog and we haven't gotten to it yet. But the experience that new users are going to get when they sign up is you'll get to a recovery step where we'll say, hey, Warpcast is happy to operate as your recovery partner. We'll do like an email or telephone recovery. You can SMS recovery. You can plug in your details and we'll reach out to you later to verify on multiple factors. Or you can set your own key. So if you know where your wallet is, you can actually set that as your primary thing. You can just type in your ENS name and that will automatically become your recovery wallet. And then if you ever lose your seed phrase, you can just go to your wallet. We probably need to build a custom web page, a little tool to do this, and then you can go complete the recovery process, and then everything is live in a new address. Sweet. Second FIP is direct cast. So this is a much larger FIP. Cassie's got a new proposal for how to actually take direct casts, which right now are a Warpcast level feature. They don't really work outside of Warpcast. and actually turn it into a protocol level feature. So actually make it something that other clients can implement and actually set up to send direct cast between each other. Cassie, if you're on the call today, do you want to give a quick preview of this?
Sure, happy to do that. So yeah, if you want to click on, yeah, thanks. At a very high level, the direct cast FIP is really just essentially an enhancement on the way that Warpcast itself is currently doing direct casts. There's a couple of specific additional attributes to it that I think are important to touch on. The first is that the way that Warpcast currently handles multi-device is leveraging a synchronization mechanism that ensures all the devices that are under your account are essentially keeping the state of each conversation ratchet and your primary identity keys, sign pre-key, etc., in sync with one another. In the case of the decentralized direct casts, we consider that to be something that is not really tenable to do in a decentralized way, especially in a safe way. So instead, we're opting for the use of what is called triple ratchet, which is an extension of double ratchet that basically takes if you're familiar with double ratchet, it's basically a Diffie-Hellman ratchet, and then subsequent keys are iterated on with a key derivation ratchet. Triple ratchet precedes the Diffie-Hellman ratchet with what is called a distributed key generation ratchet. And in particular for the hubs case, it's an asynchronous DKG ratchet. Very simply put, it's essentially constructing a instance of Feldman verifiable secret sharing in order to have all parties mutually agree on a public key, and each party holds a piece of a private key that can collectively be used to do threshold Diffie-Hellman in the Diffie-Hellman ratchet. What this essentially enables is each device now gets its own set of keys. Instead of having to manage synchronization, synchronization is no longer necessary between devices under an account. Each device just has its own keys, and this is a way to make that work very simply instead of having to have some kind of synchronization mechanism and holding data for a longer period of time so each device can get a hold of it. It makes keeping track of state a lot easier. So the other thing that's important to note about it, and I think this is probably going to be one of the more interesting pieces, is the addition of ring signatures around authorization of messages. Because these messages are encrypted end-to-end, and the goal is to make it not something that is traceable to individual users, so two users communicating with each other, ideally should not be identifiable. Like you should not be able to notice that these two users are actually talking to each other. So we employ the use of ring signatures that are based on the addition of an inbox key per device that basically dictates, hey, if you're wanting to reach me, this is the public key to point to, but and this is also the key that I'm going to be using for signing in the ring signature context. So in order to do that, basically you have to have some way of reconciling the individuals that are allowed to talk to each other in the current implementation case, where right now direct casts are permission. You follow somebody, they follow you, you can start talking to each other. In a centralized server sense, that's easy because we have that information explicitly. We can not log that information when it happens when two users are talking to each other. That's straightforward. That's basically how Signal is able to get around the logistics of trying to ensure that this conversation is anonymous. But in the decentralized case, if a rogue hub operator wants to just watch all this, that's a problem. So instead, what you can do in order to enforce users that wish to ensure that only people they mutually follow can talk to them is when you elicit to start a conversation, you will submit that initialization message and use a ring signature that is your key plus the public keys of a few other mutual follows, up to some kind of like security parameter, however much you feel comfortable with in guarding your overall anonymity in that set. And because of the nature of ring signatures, you can produce a signature that is not specifically identifying you, but is just guaranteed to be a member of that set. Those are the two particularly big pieces, the things that stand out.
Cool. Thanks for walking through that, Cassie. Obviously, this is a very, very dense FIP, maybe the most dense one we've written, and for good reason. I think getting encrypted direct messages done in a way that's actually propagated over a decentralized network is really, really hard. And so we've started on this design problem early, but it will probably take a while before we triangulate on it, get it battle tested, and actually get it shipped. But we wanted to share an early draft of what we're working on with everybody. So particularly people who are working on cryptography, who are interested in this, can reach out if they have ideas or thoughts on this approach. Cool. That brings us to the end of the stuff that we wanted to share in terms of what's being worked on in the pipeline. Have a couple of shout outs here. So thanks to DF for actually finding some improvements in the Postgres adapter example and patching them. So thanks for that PR. And then Aman, Manan, and Vern have been very helpful with finding and reporting issues to the hubs that have made it easy for us to track down and catch them. So appreciate you guys opening the issues and reporting all that to us. One other thing, if you're running a hub and if you're having issues or running into bugs, let us know. If you've been running a hub and you haven't looked at it in a few weeks, please take a quick look and just see if everything looks okay. If there are issues or problems, we would love to know and collect more details to help debug those things. That brings us to the end of the call, and I'll open it up for questions in case folks have items that they want to ask about things that we talked about today, or just open-ended questions about the protocol.
So I had one just on the storage and paying for storage. I'm sorry if I missed this, but it was essentially users paying hub operators for storage units on their hubs, right? That's essentially what's going on there.
So the way storage is going to work is you pay storage to a central contract that's run by the Farcaster protocol, and that collects all the payments for storage today. And early on, I think it's going to be a small amount of money, so we're going to figure out how to appropriate it to the right cause. But I think there's two basic ways in which we'll appropriate it. One is towards people who are making improvements to make hubs cheaper and easier to operate, so funding developers who want to go work on that. And the other is direct subsidies to hub operators, if that helps and encourages the growth of most hubs. But I think the guiding principle that we will use to make the decision is which of these methods is actually going to incentivize greater decentralization of the network. And we sort of know that, in an ideal world, payments would go directly to hub operators. But I think as soon as you incentivize and add a fee to that mechanism, people will be incentivized to build hubs that game the system, hubs that pretend to store all of the data on the network, but don't actually store the data on the network, and then spin up thousands of them so they get, a share of the fee. So we actually want to figure out the right way to reward these hubs, which is actually something that no other network has figured out. A lot of people have tried to build incentive protocols for running nodes and making data availability useful, but they've all been gamed, and I don't think anyone has figured out a incentive-based mechanism to do this correctly. So we want to be thoughtful about if and how we allocate funds to hub operators, that it actually goes to people genuinely running hubs, and it actually incentivizes the growth of more hubs. Cool. All right, open it up for questions again, in case anyone has anything they haven't asked. Oh, Manan.
Hey, so just a meta point here. I feel like we cover a lot of features during the dev call, but not as much operational stuff. So for example, operational health of the network, how we're doing, any plans with regards to kind of monitoring that, as well as any other tooling that Farcaster team might be building around the monitoring of hubs and replicators and other things that are being put out. Yeah, just a comment, but I'm wondering what your thoughts are on that.
No, it's a really good question. We actually had something that was close to being ready to show on this call, but wasn't quite yet, so I yanked it at the last minute. Some of you who opened this doc earlier might have seen a glimpse of it, but we're starting to monitor the network in a couple of different ways. One is from just user and data health perspective. How many people are signing up? How many users are active? How many different applications are publishing messages? And so we'll have some metrics that we're watching every week on how that's growing and evolving. Two, I think there's a second set of metrics, which is how are hubs doing? How is the data flowing between hubs? How many hubs are running? How long does it take a message to go from one hub to the other? And so we've actually been shipping a bunch of instrumentation that allows us to capture all this data. Shane, Sanjay, and a few other folks have been working on this. So hopefully by the next dev call, we'll have an early preview of those dashboards to show you guys.
Awesome. Yeah, super useful. Thanks.
Cool. All right, folks. Thank you all for coming today. I know we're at time, so we will wrap the call here and see you all again in 2 weeks. And we will return to our usually scheduled time of 10 a.m. Pacific. Talk to you all soon.